Hi again. Remember last time we were talking about multiplying fractions? We're going to do multiplying the division, but just a little bit too much, so I decided to split it in two groups. So we're going to talk about dividing fractions, but to begin with, we'll do just a little bit of a review and a little different setup on fractions that you might have to be able to deal with. Fractions are fractions, and so if I have a problem like this, a divided by 2 times 4 over 2a. And what you have to tell yourself is we're multiplying fractions here. That's what's going on. And then we remember what we do. What's the first thing we do when we multiply fractions, if we're smart? We reduce. Okay, how do we reduce? By looking for common factors in the numerator and denominator. And it can be anywhere in the numerator, anywhere in the denominator. Remembering, of course, that we multiply the numerators together to get the numerator and the denominators to get the denominator. So anything that's anywhere in the numerator or anything that's anywhere in the denominator is fair game. So we look at this and we start just like we did before. Here's a factor of a. Now, I may not know what a is, but it is a number. And so if there's a factor of a anywhere in the denominator, since this one's in the numerator, then they cancel each other out. So I look down in my denominator, and sure enough, over here in the denominator is a factor of a. So those will cancel each other out. Now I come down here, this 2 is in the denominator, so I'm going to be looking in the numerator to see if there are any factors of 2. So, sure enough, I can find a factor of 2 up there, so I divide out the common factors. I don't quit until I'm done. Jenny Craig principle says you reduce until you're done. Okay, so we got to keep going, and then sure enough, I look over here in my numerator, and down in the denominator, there is still a factor of 2, so those cancel out. Now that I've got everything canceled out, I multiply my numerators together. I've got 1 times 1, which is 1. My denominator is 1 times 1 times 1, which is still 1. And any number divided by itself, even 1, is still 1. So our answer is 1. Now, one thing I want to make sure you understand. Do you need to be able to look at this where we started and see this as the result? Absolutely not. I'd be a little nervous about you if you could. Most of us, we just need to learn the process and follow the process. If we do, we're going to get to the answer. So don't worry about it. Don't worry about anything in math until you need to. It doesn't help. It just sometimes creates problems. Okay? Let's try one more. We'll make this one a little bit complicated. We've got 13x cubed over 4d squared times, and I've got 16d over 39, should memorize this better. This is x squared. Now that looks pretty terrible. And if you let yourself, you could get panicky looking at this and then your brain wouldn't work, you wouldn't be able to do it. But watch what happens when all we do is look at just one thing at a time. Okay, so we start here, and we always do the numbers first. I look for 13. It's in the numerator, so I'm going to be looking for any factors of 13 anywhere in the denominator. Well, hopefully I know my numbers well enough to know that 39 is 3 times 13, so I can divide out the factor of 13 out of 39. That leaves a 3 there. Now, we always finish any one spot before we move on, because we want to make sure we don't have to come back to it. We're done. So now I'm going to look here. what you have to remember here is that exponent, that little number, tells you how many factors you have. So when I look at this, I see 3 factors of x. They're in the numerator. So when I look down at my denominator, I'm looking for factors of x. And sure enough, over here, I see 2 factors of x. Well, if I got 3 here and 2 here, how many are common? 2. So that's what I get to take out. So if I take out 2 of these, there were 3, I take out 2, I have 1 factor of x left, and both of these are gone. Okay? Now, there's nothing left we can do, so now we move on to the next one. So I start with the numbers. I've got a 4 here. It's in the denominator, so I'm going to be looking in the numerator. Are there any factors of 4 in the numerator? Well, yeah, there is. Sure enough. So we can take a 4 out of there and a 4 out of there. Okay, now we come over here to our variables. We have 2 factors of that number, whatever it is. We have 2 factors of that. It's in the denominator, so I'm going to be looking in the numerator. In the numerator, there is 1 factor of that number. So the one that's common, there is 1 common. So I can take out the common one. Now I just do one quick check here. Got a 4. Just make sure I can't do anything. I look down here in my denominator. All I've got left is a d and 3. There are no factors of 4 left. So that means I've done all the reducing I can. Now I'm going to go ahead and do the multiplication. All right? Multiply 1 times x times 4 times 1. We always write the number first just because it makes more sense to us. So I'm going to have 4x in my numerator. Now I'm going to look here and I've got a d and a 3. Number again first. So there's my number. So my answer is 4x divided by 3d. Now that was really ugly when we started, but if we just did one thing at a time, it was pretty simple, wasn't it? And that's what you've got to do. You've got to get yourself to the point where you can do that. Now we're going to talk about division with fractions. Okay, division by definition is just multiplication by the inverse. Now that may not mean anything to you, so let's just go through a demonstration so that you can see it. Okay, I'm going to multiply 8 times 1/2. And I recommend whenever you're dealing with fractions, make everything look like fractions because then your brain has a better time figuring out what to do. So we're going to make this 8 over 1 times 1/2. Now remember, we're not going to reduce this one first because we want to demonstrate something here. We multiply the numerators together, so I go 8 times 1. That equals 8. Multiply the denominators together. 1 times 2 equals 2. So when I do this multiplication, I get 8 over 2. Now, just listen while we say it. I'm going to say it in reverse so that you can see why that definition that I gave you is what it is. When I divide 8 by 2, that's the same thing as multiplying 8 times 1/2. But if you look at 1/2 and 2, I'll put an equal sign there. What's the relationship between those two? Well, 1/2 and 2 are just inverses of each other, or flipped over. All right? So, dividing 8 by 2 is the same thing as multiplying 8 by the inverse of 2. That's what that definition means. So, whenever we talk about division, we're really going, we saw how challenging it is to get the brain around the idea that multiplying fractions, what it's all about. It's even worse with division. So we just basically make this rule: we do not divide by fractions. Since division is multiplying by the inverse, we're not going to divide by fraction. We're just going to multiply by the inverse. Okay? Division is just multiplication by the inverse. So that you can see that that's really true, that it actually works. If I have a problem that says, let's say I have 3/4 divided by 1/8. 3/4 divided by 1/8. Now, 3/4 divided by 1/8, according to the rule we just got, it's going to be the same thing as 3/4 times, we don't divide, we multiply by the inverse. In other words, flipping times, dude. Flip and times, dude. So I'm going to flip that one over, the 1/8, that's going to give me 8/1, and now I'm going to multiply. Now, when I'm multiplying, now I'm going to shift gears and I'm going to go over to multiplying fractions. Remember how I do that. What's the first thing we do when we multiply fractions if we're smart? We reduce. So I look here, no 3's in the denominator. I look here, oh, there's a 4, and there's a factor of 4 in the 8. So I can divide out that common factor. And when I do, now that everything's divided out, I multiply the numerators to get the numerator. So 3 times 2 is 6. 1 times 1 is 1. So 3/4 divided by 8 is 6. Now, there's something we can do here to kind of get a visual image that this actually is true. If you will remember, when we talked about division, we said we want to find out how many groups of something there are in something else. So if I write this, what I want to know is how many 1/8 there are in 3/4. Let's do a visual on that, see if we can see it. First of all, we'll get our 3/4. 1, 2, 3, 4. Okay. 3/4 will be this part here, surrounded by purple. I hope that's camera does color so you can see that. Not very straight, but can you see that the purple part is 3/4? Okay, so I want to divide it by 1/8, so I want to find out how many 8ths there are in the 3/4. Well, remember, if I'm talking about 8ths, there have to be 8 equal ones. So if I split those 4 in 2, guess what I've got? I've got 8 equal pieces. By taking the 4/4, splitting them in half, I've got 8. Look how many there are in the 3/4 part. The 3/4 part is the purple, and if you count those, you got 1, 2, 3, 4, 5, 6. Sure enough, there are 6 of these 1/8 in 3/4. Still not really clear and easy to see, but at least we can see that we got the same result. There are 6 of these 1/8 in this 3/4. So, it works. We don't multiply by fractions. We flip in times, dude. We multiply by the inverse. So, let's just try a couple of these to see. Make sure we're clear on it. We know how to do it. So let's say we've got 5/9 divided by 4/9. The only thing we do when we're dividing fractions is to flip in times. We don't do anything but multiply but we do it by the inverse. Now we're dividing the 5/9. That's not going to change. The operations we're performing are going to be on the 5/9. So it's this one that we flip. So that will give me 5/9 times, when I flip that over, I'm going to have 9/4. I said when talking about fractions that generally start here and work your way around, but when you see something really obvious, and I think probably you can in this case, when you see something obvious, it's okay to take that out. There's obviously a common factor of 9 there. When you look at what's left, there's a 5 in the numerator, 4 in the denominator. They don't have anything in common. So now I'm just going to do my multiplication. Numerator times the numerator, 5 times 1 is 5. 1 times 4 is 4. So 5/9 divided by 4/9 is equal to 5/4. And you can see that that would be a little bit difficult to visualize how that works, but it does work. And so sometimes you just have to get your brain to say, this is the way we do it. If we do it this way, we're going to get the right answer. So I do it, I get the answer, and I say to myself, I did what I was supposed to. I know I'm right. Of course, it's always good to check, make sure I didn't make some little silly mistake. Okay, let's do one more example, and then we'll call that good for today. A little easier than last time. But let's complicate it a little bit. Let's make it one of those strange ones that have numbers in them we don't know. Let's say we've got 4a over y cubed divided by 12a cubed over 3y to the 4th. Okay, that's going to be our problem, the one we're going to end up on today. Now, first of all, is there anybody in here who has trouble looking at this and seeing fractions? I mean, the form of fractions is the form of fractions. What they actually look like depends upon what we're talking about here. But these are two fractions, and we are dividing. So we're going to do what we always do when we divide fractions. And just like we did with the multiplication, remember, first of all, we've got to change it to a multiplication problem, so let's do that first. We don't divide, we multiply by the inverse. And make sure you remember, we don't do any reducing until it's multiplication. We only multiply, or we only reduce when we're multiplying. So let's take care of that first. That's going to give me 4a over y cubed. This is not the one we flip, it's the other one. That's going to be multiplied by 3y to the 4th over 12a cubed. Now we're ready to do multiplication. The first thing we do when we multiply is reduce, if we can. Sometimes we can't, but if we can, we would do that first, because remember, we don't want to have to deal with some great big huge number and reduce it when we can do it first, when the numbers are smaller. So let's do that. Okay, start with the number. Here. Is there a factor of 4 anywhere in the denominator? Sure, right there. So we can divide a 4 out of there and a 4 out of there. Now we're going to deal with our variables. We have a factor of a here. It's 4 times a, so that makes a factor. Down here, how many factors of a do we have? Okay, remember the exponent tells you how many, so we have 3. How many are common if we have 1 here, 3 here? 1 common one. That's what we get to take out. So we take out that one, and we take out one of those. Now we had 3, we took out 1. What's left? 2 of those factors. Okay, so now we come down here and we look at what we have here. We have 3 factors of y. They are in the denominator, so where are we looking? In the numerator. Looking up in the numerator, do you see any factors of y up there? Okay. How many? 4 of them. If I have 3 here and 4 here, how many are common? Okay, 3 of them. So I can take out those 3. I can take out 3 of those. I had 4, so that means there's going to be 1 left. All right. Now I come up here. And again, I don't quit until I'm done. So I start here with this 3. It's in the numerator. Where am I looking? In the denominator. Do you see any factors of 3 in the denominator? Absolutely. Right there. So those factors of 3 cancel each other out. Okay, what we've got left now, after we've done all of that, we've got a factor of y there, and we've got 2 factors of a there, and nothing else but 1s. So 1 times 1 times 1 times y leaves us a y in our numerator. 1, I didn't write it down, 1 times a squared leaves us an a squared in the denominator. And we're finished. As ugly as that was when we started, just think about it. Because this is what you've got to learn how to do. You've got to convince yourself that if you do this 1 step at a time, that's all you have to worry about. And when you're doing a step, that's all you think about. And if you do, you'll be able to do them. So you don't go into panic mode when you look at something like that. You just think, 1 step at a time, it will be fine. And it is. So there you go for division with fractions. Practice with it, get comfortable with it, and then let's go on from there. Thanks for coming.